Hi everybody, today we're going to learn how to subtract mixed numbers. Our learning targets for today are: I can subtract mixed numbers with like or common denominators, including those in number stories, and I can subtract mixed numbers with unlike denominators, including those in number stories. So we're going to start off with 1 3/4 minus 2/4. So we have one mixed number here. One mixed number, and we're going to subtract just a regular fraction. So 1 3/4 I have pictured here. I have one whole here, and then 3/4. Okay, so we'll just take away 2/4, 1 2/4, and we're left with 1 and 1/4. Pretty simple. When we look at this just within the problem, without drawing a picture model to go along with it, we can look at the whole number part. 1. 1 minus nothing is 1. 3 minus 2 is 1. And then fourths are fourths. Okay, let's try another problem. Let's try 3 1/3 minus 1 2/3. Does this one look a little bit different to you? It should, because we can do 3 1/3 minus 1 2/3 because 1 2/3 is smaller, of course, so we're not going to go into negative numbers. But when we try to do 3 minus 1, well, that works. 3 minus 1 is 2. But then when we try to do 1/3 minus 2/3, well, that doesn't really work anymore, does it? Because 1 minus 2 is -1. So I don't really think I want to go into the negatives, because then I would have 2 and a -1/3, and that's just kind of goofy. So I don't think that's such a great solution. So let's try something a little bit different. I'm going to get rid of all of those. Instead of doing that, I want to think about 3 1/3 in a slightly different way. I'm going to think about 3 1/3. I'm going to break one of those wholes apart, and I'm going to break it into thirds. So one whole, we know, equals 3/3 in this situation. So I'm just going to move over this one. We've got 3/3 underneath. So now we have really 2 4/3 minus 1 2/3. Now we can do 2 4/3 minus 1 2/3 pretty easily. So I'm going to take the 2 4/3 that I have, and I'm going to subtract, or I'm going to just actually take away, and you're going to see me take it away, 1 2/3. So I'm going to take away one whole and then 2/3. So we're left with 1 2/3. When we do this on paper, we're going to look at this as 2 4/3 minus 1 2/3, right? And then we can do 2 minus 1 is 1, and then 4/3 minus 2/3 is 2/3. So combining the two parts of our mixed number, we have the 1 and we have 2/3. So our final solution is 1 2/3. So those two match. Let's try another one like this. Let's have 6 wholes and take away 1/4. Clearly 1/4 is much smaller than 6 wholes. But it's not easy to take away a fraction when we have a whole number. So instead of 6, I want to think about this as 5 5/4. So I'm going to just take one of those wholes and break it into 4/4. From here then, I can pretty easily take away 1/4. And then I'm left with 5 wholes and 3/4. so 5 3/4. If I was going to write this down, I would rewrite 6 as 5 4/4 minus 1/4. 5 minus nothing is 5, and then 4 minus 1 is 3, and then the size of our piece doesn't change, fourths. Okay, here's a follow-along problem. So I want you to try to do this one on paper. So you're going to have to do some trading. The 4, you're going to have to trade out one of those wholes to subtract 1 4/5. So pause the video, try it on paper, and then unpause and I'll show you how to solve it. Okay, I hope that you tried to solve that problem. Let me show you now how to do that. So we're going to trade out one whole for 5/5. So the 4 becomes 3 5/5, and then the 3/5 stays where it is, 3/5, because we haven't taken any away yet. 3 5/5 plus 3/5 is 3 8/5. And then we subtract 1 4/5. Do you see how I'm taking the time to actually rewrite the mixed number as a mixed and an improper? That's important because we want to make sure that we're knowing what we're subtracting. Subtracting 4 from 8. Okay? So 3 minus 1 is 2. 8 minus 4 is 4. And then they're just fifths. Okay, so that wasn't too hard when we were trying to do mixed numbers that have like or common denominators. But sometimes we have to deal with fractions that don't have common denominators. So just like we've already learned, when we have fractions that have different denominators, the first step that we need to take is to turn them into common denominators. So I'm going to think to myself, what is a common multiple for 5 and for 4? Well, I'm going to probably just use my quick common denominator, which is 20. I'm going to turn 4 3/5 into 20ths. And I'm going to turn 2 1/4 into 20ths as well. So I'll just multiply the numerator and denominator by 4. The whole number doesn't change, whether they're 20ths or whether they're fifths or whether they're fourths. It's still 4 wholes. So the 4 wholes remain. And then I come up with 12 20ths. 2 1/4, of course the 2 stays as it is. 2 wholes is 2 wholes no matter what size those pieces are. And then I'm going to multiply by 5 and by 5. Now from here I'm going to say to myself, can I subtract 4 minus 2? Yep. Can I subtract 12 minus 5 and stay positive? Yes. So we are all set to move forward on this problem. 4 minus 2 is 2. 12 minus 5 is 7. And then the pieces are 20ths. Okay, here's a follow-along problem, just like the one we did before. I want you to pause the video, try it out, and then unpause, and I'll show you how to do it. Okay, 3 7/8 minus 2 1/4. Well, I have not common denominators. So the first thing that I need to do is turn these into common denominators. Now, I don't think I'm going to use my quick common denominator. I'm not going to multiply together 8 and 4. Because I see that 4 is a factor of 8, so I'm going to leave 3 7/8 just as 3 7/8. Because I know I can turn fourths into eighths. 2 1/4, well, the 2 stays as it is. Wholes are wholes no matter what. And then I'm going to multiply these each by 2 to get an equivalent fraction of 2/8. Always put my subtraction symbol back in so that I can keep focus of what I should be doing. Now I subtract the whole number parts. 3 minus 2 is 1. And then I subtract the fraction parts. 7 minus 2 is 5. And then they're eighths. Is that the problem? Is that the solution that you got? Okay, let's try another one. Let's try 4 3/4 minus 1 7/8. Now don't skip over this part because you need to watch what's happening because this problem is actually a little bit different. 4 3/4, I have unlike denominators, so I'm going to rewrite the problem up and down. And I'm going to now write these same mixed numbers with common denominators. Again, I've got fourths and eighths here, so I think I'm going to just turn them into eighths. It's a little bit easier. Don't need to get so big to use a quick common denominator. And that'll be a little bit easier when I want to turn it into lowest terms. So 4 3/4, the 4 stays the same. I'm going to multiply by 2 over 2. And it becomes 4 6/8. And then 1 7/8 is just 1 7/8. Now, I can try to subtract 4 minus 1 is 3. But what about here? I have 6 minus 7. That's going to put me into the negatives. So that's not a good solution. I don't want to do that. Okay? So instead, I'm going to get rid of this 3. And I'm going to turn 4 6/8. I'm going to trade out one of those whole numbers and make it 3 8/8 plus that 6/8. And it becomes 3 14/8 minus 1 7/8. Now can I do this? 3 minus 1 is 2. 14 minus 7 is 7. And then they're eighths. So that one works. Okay, here's a follow-along problem. So pause the video, try it on your own, and then unpause it and see if you got the solution right. Okay, now I showed you the full solution, so take a moment and pause and make sure that you understand what happened here. I just turned the fractions into common denominators, which were 28ths, and I had to trade one of the wholes from the 7 into 6, and then I have 28 28ths left over. So I ended up with 6 49 28ths minus 2 24 28ths. And then we ended up with 4 25 28ths. I bet you're wondering now if we can use our very cool and fun crisscross method to subtract mixed numbers that have unlike denominators. And the answer is you sure can. It's a little bit more complicated than adding mixed numbers like we saw yesterday. But let me show you how to do this. I think the first thing that I would do is take a minute and actually, maybe I'll try the crisscross and see if it works. But I'm just going to really do the fraction parts. So I'm going to do 2/5 minus 3/4. Knowing that 5 minus 3 pretty much stays as it is. So I'm going to multiply here 2 times 4 and get 8, 5 times 3, and I get 15, and then here we have 20. Well, I can't really do 8 minus 15 without going into the negative numbers. So instead of doing this part first, I think once I figure this out, or maybe you even try it out first, and then you figure it out, we'll do a little trading, and then we can do the crisscross method. So let me show you what that might look like. Instead of 5 2/5, I'm going to rewrite 5 2/5 as 4 7/5. From here, I can subtract the 7/5 part minus the 3/4 part. And we can do our crisscross. 28 is 4 times 7. 5 times 3 is 15. And then on the bottom for the denominator we get 20. Now we can do 28 minus 15, and we end up with 13/20. But now it's really, really, really important, especially if we're going to do the crisscross method, to not forget the whole number parts. Okay, so actually we ended up with 4 7/5 minus 3 3/4. So here I have to do 4 minus 3, and we get 1. So the solution is 1 13/20. Now the crisscross method, when you're having to do some subtraction with trading, is a little bit more complicated, and you have to keep your work more organized. So if this is maybe a little bit more challenging for you, don't do it and just use the method that I showed you before, which is really the same thing. It just allows you to take the time to kind of rewrite the problems. Girls and boys, adding and subtracting mixed numbers is not necessarily a quick and simple task. It's something that you're going to have to take the time and make sure your work is organized and make sure that you're writing out all of the different steps. It really is a several step process, and it's important that you're showing your work and not trying to keep all of those numbers organized in your brain, but actually showing them on paper. Okay, here's your quiz for today. Make sure that you answer in lowest terms when you go to Edmodo. Have a great night, and we'll see you tomorrow.